Okay, now I already connected all this part together and I want to measure the resistance value. So our resistance value here almost 1100, and then we will compare our measured resistance value with our calculated one, and we will write all this in the second table. So this is our here table. So this is our second table. Here I will calculate the resistance equivalent by adding all these resistance together, and here I will put our measured resistance value, the total one, and here I will calculate the percentage error and find out what is the percentage error. It shouldn't be more than 15% here. So this is our first part of our experiment. Our second part, we will connect the battery and the circuits. Okay, I will bring up my battery here, and I will connect our battery. So I need the battery wires. So this is our wires that can used for the battery. So in this way I connected the battery. So the black wire is the negative and the red wire is the positive. So I will connect the positive here as it's shown in our circuit, and the negative here also, and also it can be connected directly to the positive and the negative parts here, and I will put some wires to connect between the circuit and the battery, so that will be fine. Okay, so now I already connected all my circuit together with the source. So now I will try to follow our procedure and complete the experiment. So here it says measure the current here at point A, measure here each here you will already just put the measured resistance. Here you will measure the voltage drops of each component or of each resistors, and then you will calculate the currents. So you will calculate the currents by dividing the measured voltage of each component on the measured current or on the measured resistance, and finding out what is the current here. The total currents can be calculated by calculating the total resistance and finding out how much is the total voltage supplied to the circuit is, and divided the total voltage on the total resistance. So here, as you know already, our total resistance is 400 if you calculated the resistance mathematically, and our supplied voltage is 9 volt. So you just divide the 9 volt over 1420 and calculate the current. And here I will show you how to calculate each voltage drop for each resistance. So here our resistance and here our voltmeter. First of all, I will set our multimeter to measure the voltage. I will measure or I will set the voltage here in the 20 scale because it is the closest scale to our battery value. So our battery value here it's 9, and here the scales here the closest one is 20 volt. Then I will connect the voltmeter in a series or in a parallel connection with each resistance. So our first resistance, I will connect the voltmeter in a series with our parallel with our first resistance. So you need to make sure that the first end in the same column as the resistance, and the second end in the second column as the resistance. So here our voltage is 0.15, and then I will write here that our first voltage is 0.15 volts, and we don't forget the unit. I will do the same with the second one. So I will take now the voltmeter, and I will connect the voltmeter in parallel with the second resistance. So the first end is the first column as or in the same column as the first end, and the second end or the second wire in the second or in the same column as the second end of the resistance. So in this way I call the connection here and here it's parallel. Okay, so our value here, it should be or it is 0.24, and I will also write the value here 0.24, and so on. I will complete the same with the same components, or with the other components. So I will now connect the voltmeter with the third elements and measure the voltage drop. So here it's connected with the third resistance. Okay, and here the voltage drop is 0.33, and as you can see, the more resistance we have, the more voltage drop also will have, because the relationship between the resistance value and the voltage drop is proportional, or it's linear. So the more we have, or the more resistance we have, the more voltage drop we will have also. So the same with the last resistance. I will connect the voltmeter in parallel with the last resistance. So, and I will measure the voltage drop, so almost 0.66, and I will write this one here 0.66. So here, to calculate the current, I will divide the voltage drop over the resistance value and find out what is the current of each resistance. You will notice that these four currents have the same value, which means that in any series connection, the current following in the series will be the same, or in the circuit will be the same, and it doesn't alter, or it doesn't change with the components. So here the total current, it will be the same as the current in each of these components, because the current in a series connection will be the same, it doesn't change. But the voltage drops here, as you can see, will be changed depending on the resistance value. So the more resistance we have, the more voltage drops also will have. Okay, let us now complete for the second column. So in the second column, I will write up all the measured voltage drops here, okay, from the last table, and I will calculate the drop or the voltages mathematically by multiplying the total currents I already found in the table above, or in the first table here. So the total, or the measured total here, or the total current measured here, I multiplied the total current by each resistance. So what is the resistance, or the first resistance value, and then I will put the results here, and here I will calculate the percentage error and find out how much is the percentage error between the calculated value and the measured value, and so on with the others value. Okay, so that will be all just calculations. Final step here, as you can see, I will sum all the voltage drops here for the first four resistors, and I will put the summation here, and then I will subtracted the total supplied volt, which is the 9 volt, from the summation of the four resistors voltage drops, and I will verify that the remaining voltage drops will be the same as the voltage drops of the last unknown resistors voltage drops. Okay, so we haven't calculated, or we haven't measured the voltage drops of the last resistors, so we just measured the first four resistors voltage drops. So we can here find out that the last voltage drops of the last resistor will be resulted from the 9 volt battery, and subtracted the 9 volt battery from the summation of the first four voltage drops, and we will find out how much is the voltage here. So here you will put here the subtracted results from the last table, and you will you will measure the voltage drop by using the voltmeter, and you will compare all these two results, and you will find out the percentage error and explain why, if there is any difference, why there is some difference between these two measurements. Okay, so that will be the end of this part of the experiment.